Good morning, everyone. This is Shauna, and I'm coming to you with another video to answer some questions that have been asked from the classroom regarding the last two homework assignments, specifically some issues with section 2.1. So let me address those first, and then I'll go back to something else that came up. Let me share my screen at this time. So this is from section 2.1 in your book, and I wanted to point out something. It's regarding, let me go back a few pages here. It's regarding the difference between class boundaries and class limits. Okay, so when we construct frequency distributions, grouped frequency distributions, we have class limits, we have class boundaries. Class limits do not overlap. Class boundaries do. So let me, at this point, let me show you that. So this particular exercise, if you look at in the book, if you look at exercises 5 through 8, it says find the class boundaries, midpoints, and widths for each class. So here the assumption is they've given you class limits. Otherwise, they wouldn't be asking you to find the boundary. So let me show you that. Let me put it on the whiteboard. So let's assume here that bear with me for a minute. Let's assume. So let's assume that we have our class limits as 43 to 47, okay? Now, we don't have another class, which doesn't normally happen. Usually we have data, we've made classes, which is what you see in the PowerPoints. This problem is a little bit artificial because it doesn't give you any of that. So what we actually have to do in order to find the width, which is the question somebody asked, is how do I find the class width if all I have is the class limit? The answer to that is you have to find class boundaries first. Now, how do I find class boundaries? Well, class boundaries are always one decimal place more than the limits. So as we can see here, these are whole numbers. They don't have decimal places, okay? So you would want, in this case, we want it to have one decimal place. Now, the other thing is they always end with a 5. So here's the rule. It's one more decimal place than the original data, than the original class limit, okay? And they end with 5. Now, let me show you what I mean by that. So we call the 43 is what we call the lower class limit because it's smaller than 47. 47 is the upper class limit. So what we do is we want it to have one more decimal place. So if I want to find the lower class boundary, okay, then what I'm going to do is I'm going to start with the lower class limit, and I'm going to subtract a decimal that has one more decimal place than my data that ends in 5. So in this case, minus 0.5, okay? My upper class limit my upper class boundary will be my upper class limit plus, in this case, 0.5. Okay. So what does that mean? That means that for this problem, I have the following: 43 minus 0.5. Now, it's not 5, 0.5. This is going to be 42.5. Okay. My upper class boundary is going to be 47 plus 0.5, and that's going to equal 47.5. Okay. So if you look, now we have our boundaries. So if our class limits are 43 to 47, then our class boundaries are 42.5 to 47.5. And so our width now, your width, your class width for this is going to be your upper class boundary minus the lower class boundary. And so that's going to be 47.5 minus 42.5, and you should get 5 units. 47.5 minus 42.5 leaves you 5. And that is my class width. Okay. Let me do one more example for you with a different number of decimal places so you can see how that works. Okay. So I'm going to, at this point, I'll do a new share here. I'll go back to the textbook. And let's do number 7. 8.24 to 11.36. So 8.24 to 11.36. So here we have find the class boundaries and the width for a class with limits as below. 8.24 to 11.36. Okay. Notice that this has 2 decimal places. Okay. This has 2 decimal places already. That means that our class boundaries will have one more. It will have 3. Okay. So what we're going to do is we're going to create one with 3. Now, if you want, sometimes what I encourage students to do because they're a little bit confused as to what they should do, is you make blanks. So sometimes what I do is I said, well, there's got to be 3 decimal places, right? So if you don't know what to add, you draw yourself some blanks. Or draw, because I know there has to be 3 blanks because there's 3 decimal places, right? In the last blank, or on the last blank that you draw, put a 5 in the last decimal position. So I'm going to put a decimal point. My pen does not want to cooperate this morning, ladies and gentlemen. Let me draw with a wider. There. Okay, there we are. There's my decimal. Now I want to put a 5 right here because I told you it ends in 5s. So I'm going to put a 5 here. And you put zeros for the other 2 blanks. So this is what you're going to add and subtract just like before. So here, because we have the need, whoops, that didn't work so well. Let me undo that and do it one more time. So 0 here, 0 here, there we go. Now we're going to do the same thing. This 8.24 is the lower limit. So we're going to say 8.24 minus, because remember, it's got to be lower than this. So minus 0.005. Okay. This front 0 is optional, but I just want you to remember there's 3 behind it. Okay, so I am subtracting 0.005 from it. Okay, now let me do something here. I'm going to stop my screen share here, and I'm going to bring up the calculator. You can, if you aren't comfortable calculating this on your own, you're more than welcome to use a calculator. I'll bring it up for you right now in case some of you may not be. So we have 8.24 minus 0.005. Again, the 0 in front is optional, but you need 3 places behind the decimal point. This is 8.235. Okay. Now that's your lower limit. So we're going to put it on the whiteboard. This is 8.235. Okay. So now that's my lower. This is my lower class boundary. Okay. So this is my lower class boundary. Now I'm going to take 11.36 and I'm going to add, because it has to be larger than this number, 0.005, right? So this becomes 11.36 plus 0.005 becomes 11.365. So again, these are the boundaries. How do I find the limits? Well, I mean the width. How do I find the width? I subtract the 2. So we say 11.365 minus 8.235. My width, your width can, oops, excuse me. I made an error there. Let's try it again. 11.365 minus 8.235. 235. And if you do the subtraction, you'll end up with the width here, okay? Is 3.13 is your width for that, or 3.130 if you choose, okay? If you want to make it 3 decimal places. So that is how you would do that. Let me put it on the whiteboard for you here so that we complete that. This is equal to 11 point, excuse me, 365. So you take the class width again is going to be 11.365 minus 8.235. And that becomes 3.130. Okay, this is equal to 3.130 or just 3.13, but usually we keep the class width to the same number of decimal places, okay? So our boundaries, this is my lower class boundary. This is my upper class boundary. One more decimal place down the data, okay? So that's the other situations, the midpoints, and the construction of the frequency distributions are explained for you. So this, I believe, was the only issue, but that applies to those questions there. So I hope that helps a bit. The other question that came up for people and always comes up is what to do about the, I'm going to go back to, let me, bear with me for a moment here. A couple of other issues that come up for people are the issue in exercises 1.2, where we talk about the scales of measurement. Continuous and discrete are usually not too troublesome, but the scales of measurement can be. So I wanted to go over that for a minute. So let me go here. For exercises 23 to 30, classify each as nominal, ordinal, interval, or ratio level. Okay, so let me just go over that. So we have section 1.2, levels of measurement. So nominal level just names things. Nominal comes from the word name in it, names, objects, data, people. So this could be things like, for example, what is your favorite ice cream flavor? Right? Somebody says, well, my favorite ice cream flavor is chocolate chip. Somebody else says it's butter pecan. Somebody else says strawberry, right? Whatever you say. These are examples of nominal level. Only you can name it. We can't say that chocolate chip is better than butter pecan. We don't have a way to rank them. So it's just naming it. Other common examples of this that can be confusing for people that you'll see on the homework and in the textbook might be things like zip codes. And they're like, well, that's your first inclination is that's numerical. Not really. It uses numbers, I agree with that, but it's not really numerical. It's a label. So the zip code that I live in is, for example, 90650. That zip code is a zip code for Norwalk, California. Okay. That zip code is not really acting in a quantitative way. It's acting as a label. Zip codes are also nominal. Okay. Another thing that's nominal is things like juror IDs. If you've been a juror on a trial or a potential juror, you know they give you those long ID numbers, right? And that's an example, another nominal level. Okay. Then we have ordinal levels. Now, what does ordinal level do? Ordinal levels are up a level from that data. So ordinal level. This is where we can rank data and we can comparisons of better and worse are possible. Okay. So for example, things like letter grades. Okay. Letter grades would be ordinal. For example, A, B, C, D, F. Letter grades are ordinal. We know that an A is better than a B. We know that a B is better than a C and so on. But how much better did you do? Maybe somebody got 95 and the nearest B was 89, which is not too far apart. But what if the highest A was 98 and the highest B was 81? You see? We don't know how much better or how much worse. We just know that it is better. So letter grades, places in a race, first, second, third, things like that. Those are ordinal levels. Also things like, for example, a pain scale that is something like you go to the hospital, right? And they say, what is your pain level like? Sometimes they say something like mild, moderate, or severe. Now, those are subjective They vary by the person, but for example, that would be an example of ordinal level. If you have mild pain, it's less than moderate, but how much, we don't know, okay? These are examples of ordinal levels. Now, the ones that usually give students the most problem are the last two, which are what the heck is going on with ordinal level? I'm sorry, not ordinal. Interval scale, right? Interval scale versus ratio scale, okay? These are the ones that usually give students the most trouble. Interval scales don't have what we call a true zero, okay? And what that means is that you can have a zero on it sometimes, but it doesn't necessarily mean that measurement doesn't exist. For example, the biggest example of this, there are others, but the biggest one is temperature scales. If you go outside and you read the thermometer and it says 0 degrees, that doesn't mean that your thermometer failed to register temperature. It means that it's zero degrees outside from where we start measuring where 1 and 2 and 3 and 4 versus -1, -2, -3, and -4 are. And depending on whether you're on the Fahrenheit scale, as we practice in most of the US most of the time, and or the Celsius scale, centigrade scale, the measurements are a little bit different. But temperature is an interval scale. So a temperature of 0 does not indicate no reading, right? So it's 0 relative to where we start. 0 is what we call a relative position, relative to where you are. Like an origin position, right? Temperature is a big interval scale. Generally, IQ scores, this is a little bit of a debate, but you'll see this one. I think they took it out of this book, but sometimes you'll see it. IQ scores are generally thought of as being interval scales because you can't realistically say that somebody has a 0 IQ. Even the most challenged person has some sort of intelligence. So IQ scores, no intelligence is theoretically not possible. Again, it's now contrast these examples of interval scales with, let me show you this. Contrast this with the ratio scale, which this does have a true 0, okay? Ratio scale, okay? Ratio scales have a true 0. Now, things like weight. Weight is a really good example of a ratio scale. Weight. So if you go to the store and you buy something like fruit or meat, right? You buy it by weight. How much it costs you depends on not only how much you buy, but how much it weighs. Usually they sell it by the pound, right? So they have to weigh it. If you put nothing on the scale, it will show 0 weight and you pay $0. If you put a pound on the scale, you pay however much a pound is worth. Weight. Another one, it's a ratio scale, is height. Height is a ratio scale, right? 0 height, you don't grow, right? You have a certain height. Weight, height, those are both ratio scales. Anything that has a starting position from 0, not from some arbitrary point, like we're starting from a certain point, that's a ratio. But if you're starting from 0, that's going to be a ratio scale. Okay. Height, weight, things like in certain, depending on the way the problem is worded, income. Income could be this depends on the wording in the problem. Okay, but it could be a ratio scale. But height and weight are the most common ratio examples. Temperature is the most common interval scale. I hope that clarifies a bit. And that's as much as I wanted to clarify in this video. If you have more questions, feel free to either drop me an email or drop them below this video, and I'll be glad to try and address them in a future video. Good luck, everyone. Stay safe, and I will talk to you in my next video very soon. Thank you, and bye for now.